In this lesson, we are going to begin to talk about antiderivatives, which is then a bigger part of a small piece of what's known as integration. So an antiderivative is kind of what it sounds like, where you are going to undo a derivative. So if you remember, if you have some sort of a function, we do a derivative, we kind of label it like this, we're going to go backwards, right? And so we have an f prime, it's going to go back to original function. If you do have one that looks like this, when we go backwards, we just turn the lowercase f into a capital F. And that's kind of how we would symbolize this was your original function if this is the derivative. So a little bit of what we got going on is that if you were to do, so the idea is we're doing exactly an antiderivative. We want to know, what did it come from? So if we were to do the derivative of x, we get a 1 out of it. So then wouldn't the antiderivative of 1 just be x? Kind of. Awful close to that. Because the problem with that idea is that if you do the derivative of x plus 4, you get 1. Derivative of x minus 7, you get 1. Derivative of x plus pi, you get 1. So it's a little bit bigger than that. You have to kind of add this idea that you might have some sort of a constant kind of floating at the end of it. So here's how we would kind of end up generalizing this over and over and over again. That if the derivative of x squared is 2x, and you want to do the antiderivative of 2x, it would have came from x squared, but then you have to have some sort of a constant because you don't know. There would be more, you would need more information to know if there was some sort of a value at the end of it. So since we don't know that, we have to generalize all of our antiderivatives with, we do our antiderivative and we're going to add this plus c because there's some sort of a potential constant that might be sitting at the end of it. And we don't know. Sometimes we'll actually be able to find out if there is and what that specific number is. But a lot of the antiderivatives we're going to do is we're going to do our antiderivative and then just put a plus c on it. All right, so if we take a quick look on some kind of the basics, we'll get into a little bit more challenging ones, a little bit more of the rules to this eventually. But if you had some sort of a function that is equal to 3x squared and we want to do the antiderivative, since we don't have that f prime on it, we're just going to call it capital F of x. Kind of want to know, where did this come from? So what did this look like? We would have had an x cubed that would have turned, we would have brought the 3 down and subtracted a power. And since we don't know if there was any other kind of a value after it, we're always going to add that to the end. So there's our derivative, our antiderivative. Now this is going to turn into something that's just kind of a recognition thing that a lot of instructors don't make people memorize this. Some might, but this is definitely a recognition thing that you might get some sort of an integral chart. So here's some of the rules to it. We'll kind of go into different kinds of problems. I don't memorize a whole lot of them because I kind of have done enough of them over the years that I just kind of know how a lot of it work, except when you get down to these last couple. When you have these last couple, we're doing the antiderivatives of this. That little symbol represents we're doing an integral. An integral represents an antiderivative. So you're doing an antiderivative of this, and we don't have any square roots on ours. We have just a 1 plus x squared, which looks like this one. And so our a value is just a 1. So it's going to become that. And so our a's are just a 1. So ours, and we'll get more complicated kind of versions eventually as we get through this. But this, your antiderivative, would be an inverse tangent. And then plus some sort of constant to it. So that's not totally usually a memorization kind of a thing. It is saying, hey, I know that this is going to connect to some sort of an antiderivative. Let me look on a sheet in order to figure that out. If we're doing this one, this is a trig thing. So this, again, is not something that I'm going to probably look at a chart for it. What I can do is kind of build my, if I were to take kind of the derivatives, and I'm going to work backwards here a little bit. If we have the derivative of sine, sine becomes cosine. If you do the derivative of cosine, it becomes negative sine. Derivative of negative sine becomes negative cosine, and the derivative of negative cosine becomes sine. So here's where we're at, and we're moving backwards to that one, because if you do the derivative of it, you get this. So we want to know what was the original before you did the derivative. So the antiderivative of sine x would be taking it back a step, and we would get a negative cosine x, and then we'll add a plus c onto it. All right, so that's a little bit of an introduction. We'll go into a little bit more of the rules to this, and just kind of see how challenging they become on the next video.